All right, thank you all for joining us here at VMware Explore, and in this session we have Kubernetes Core Concepts. I'm Ryan Schneider.
I'm Neil Winton.
And we're going to do 4 sections, just a quick overview of what this course is and what the academies are, which we're going to talk about a little bit, the logistics of it. And then we're going to get 3 short discussions on Kubernetes recapping, resource management, and if there's time, we'll go into Kubernetes networking, but usually it's been running where we don't. So my name is Ryan Schneider. I'm on VMware here on the Tanzu learning team. So create educational content as well as manage a lot of the lab infrastructure that we use, which is a different set than the core HOL, as you'll see in a little bit. Love Kubernetes. I moved to it. Came to VMware from Heptio, a company, Kubernetes company. Before that was Elasticsearch. And then I've done, prior to moving into infrastructure and cloud native space, I did a lot of Java development and architecture.
Hi, and Neil Winton. I mean, you can read that stuff if you like. I've been working in software for 40 years, or thereabouts. A lot of that time in the UK, working for British Telecom, worked for a number of other companies as well, worked for Accenture, worked at JP Morgan, all sorts of stuff. But actually, in more recent years, I've been more concerned with helping other people learn from all of the mistakes that I've made over the years. And now working alongside Ryan in the Tanzu learning team, and myself learning all about Kubernetes and all the wonders that brings to us. So, and I think, yeah, we're being recorded as well here, so.
All right, awesome. So, a few things. Neil, myself, and some of our colleagues, we maintain 3 of these academies: Kube Academy, Tanzu Academy, and Spring Academy. We run them all off the same platform, and as you can see you can probably guess what content's where. Real quick, by attending this session, you all are going to get a 30-day free trial to the premium content on Tanzu Academy. So if you happen to leave early or on your way out, come by and see us, and we'll have you personally type your email into the submission form, and then you'll get an email with the invite. I believe it goes till the end of next month, the end of September. If you need more time, contact us, we'll let you know. Kube Academy we're going to do a subset of the content from that today. And all the content there is free, and it's around open source and cloud native technologies. And we separated this because a lot of the Tanzu stuff from VMware is based around a lot of open source frameworks and tools. So we have training over there dedicated to that, and then we layer on the Tanzu specific stuff on Tanzu Academy, and then Spring Academy is for the Spring ecosystem and community there. So on the Kube Academy, that's what we're going to use today to launch our labs and everything. Training provided by VMware. The login for it is your Customer Connect. If you have an account there, you'll just plug those creds in, it should work. If not, it's pretty simple to make one. We have web-based labs, all terminal-based, so terminals in the browser. All the content on there is free, and what we're going over now is a subset of a larger learning path. So what we did for this, we chose what we felt was some interesting content that was sort of in the middle of beginner to some intermediate stuff with fun lab exercises and some fun lecture content with it. And so what we'll do is we'll have you go to this URL on your machine, so we have it scattered throughout the deck. You'll want to do this in the native browser on the machine because there's some proxy firewall issues inside the HOL for this.
But you do need to launch the HOL lab first, because they'd like to track that you've turned up.
Yeah.
And I think you might earn stuff as well. Possibility of getting prizes, I don't know. Mm-hmm. Somebody told me that. But anyway, yeah, so we'll make sure everybody's set up at the right point when we get to that in just a few minutes.
And we're going to pick some content out of this larger learning path, but it's going to be okay because we're going to bootstrap you at the beginning of every lab right to where you need to be. So if for some reason these labs build on each other and you had some trouble with one of them, no problem, we get you back in. And then also if you'd like to go back and do this at your own leisure later on this weekend, next month, whatever it may be, yeah, you can. We have links for that all in the stuff that you're going to go to. Another thing to note is we like to carry a theme throughout courses and that are connected. And so we use this same 2-tier web application throughout all of that learning path. And that's both here today and if you continue learning on Kube Academy. It is a MySQL backend and a web front end that talks to it. It happens to be Golang because in the Kubernetes world, we like containers that start up quickly, and Golang is very friendly for that. We'll see more of this, but just if you wonder like where these words came from and what it is and why are we assuming that you know about it, that's why. And so what we've done is we have a nice Explore 2023 page here. Every time we go to labs, we'll pop this up on the slides in case you lost it in the browser tab. And it's the same agenda we showed earlier, and then the direct links to the labs so that we're good.
Although
yes.
it looks slightly different from that now, but hey.
Yes.
Yes.
Oh yes, I forgot to update that screenshot.
This is the third iteration of this course here, and you've got the best iteration, okay?
Yes. So Neil's going to go over some quick recap on the why behind Kubernetes, why we're doing it, and the core concepts, and then we're going to go on and talk more about deployments after that.
Okay. Thanks, Ryan. So, can I have a quick show of hands first? So, who here is a Kubernetes virgin? Okay, yeah, okay, yeah. Who here is a Kubernetes expert? That's good. Okay. So, appreciate that people are starting this at different places. So we'll do a little bit of a very lightning introduction to Kubernetes, some of the core concepts there. This is Kubernetes Core Concepts, but there are an awful lot of things that we could be covering. So let's start with Kubernetes as your air conditioning system. What? What is Kubernetes for? What is its real purpose? So it's described often as a container orchestration system. Grand term. What's it about? The fundamental purpose of Kubernetes is you tell it what you want your system to be, what you want the state of your containerized world to be. You want 15 instances of this and 30 of that, and just make it happen somewhere in the cloud. That's kind of where we're going. And it has, you may be very familiar with a lot of tooling that is, you tell stuff exactly what to do. It's a bit like, I had a car that looked like that once upon a time, and forever, particularly in the UK, where the weather's very changeable. I mean, here, I suspect in Las Vegas, you set it to cold and that's it. It wasn't like that in the UK, and the sun would be out and you'd be forever twiddling it between hot and cold or whatever. That was the old way. Of course, much better way is, and I do have a nicer car now, that I just say I want it to be, well, I say I want it to be 21 degrees Celsius because I'm in the UK, but 72 degrees, just make it so. And that's the, although it's not always obvious, the fundamental purpose of Kubernetes under the cover is you say, make it so. And its job is to respond to whatever happens in the environment. You say, I wanted 15 instances of this container running, it will find a way to keep 15 instances running. If things crash, if node goes down, it will reschedule stuff. You say, this is the desired state. So one of the things always to keep in mind about Kubernetes is, however else it may look, what it's trying to do under the covers is maintain that state of the world. That's its raison d'etre. That's its purpose in life, is you give it your idea of the state, and it will do its best to maintain that. Which is why actually even just deploying a simple application on Kubernetes, simple containerized application on Kubernetes can bring great benefits, because it does stuff like automatically restart. It finds the right place to run it. It makes sure there's resource. So one of the attractions just of Kubernetes at a very simple level is that. So here are some fundamental concepts, and we're going to look a little bit at each of these, I guess, in what we do. Now, I've talked about containers. Now, who here is not familiar with containerize applications, Docker, etc. Anybody think, I've never heard of that stuff at all? No, great. Everybody, I think, is aware these days to some degree of containerization as a technology, and some of the benefits that brings. So why don't I have containers here as a fundamental Kubernetes concept? Well, we'll cover that in just a minute, but really the basic unit of what Kubernetes deals with is a thing called a pod. And we'll look at that in just a moment. So yes, it deals with containers, but actually you'll find most often people talking about pods. Other concepts, services, and you will find analogies for all of these things in stuff that you know already. So if you're already dealing with VMs and firewalls and load balancers, whatever, a lot of those concepts that you already really understand very well translate directly into Kubernetes. And deployments as that other concept, again, we'll dig down on that in just a moment. So what's a pod? What is a pod about? Well, first thing is, perhaps the simplest mental model is, think about a pod as your ideal virtual machine for an application. So one of the reasons, a pod has one or more containers, but the main purpose is usually because of one thing. But often when you deploy an application, yeah, it's great. You might have a web server, but you often want to deploy something alongside it. So the pod kind of recognizes that, yeah, often it is just, I'm just running one process. That's one thing I care about. But often there's a set of things that are really closely related, and I want to be able to treat those as a unit. And we'll, again, look at this in just a moment. And so the assumptions that go with this is that all of the containers for a pod, they need to be really closely together. They will all run on the same node, and they need to talk to each other as efficiently as possible. So they talk to each other over the local host interface, and containers share the same volume. So as I say, in some ways it's kind of your idealized, here is the VM that contains everything I need to run these closely related set of processes. Now, it's more lightweight than a full virtual machine, but if you've got that kind of mental model of what it is, that's a good, useful starting place. And in fact, here's a diagram. So in this pod may be, the main purpose of it is to run a MySQL database. So that's fundamentally what you want this pod to be doing. This is representing something that's running a database. And that database is going to be exposed to the rest of the cluster. It's going to be exposed to port 3306, standard MySQL port. But I actually want to run alongside it a whole set of other containers. So something that maybe is doing monitoring, is reporting off to a centralized monitoring infrastructure, something's doing logging. But all of those things are sharing access to the same file system, so a shared volume, and are able to talk to each other as efficiently as possible. So the other thing there about a pod is that, within that pod, those containers talk to each other over localhost. The pod itself has an IP address that it exposes to the rest of the cluster. So again, treat it as a kind of micro virtual machine. So your VM would have an IP address. It would have a port exposed on it if you were running the database like that. Think of it perhaps in that way. So again, some of you appreciate will know that, but if you haven't come across that before, that's why. Services. So mentioned services, mentioned analogies with things that you already know about. Now often, of course, you're running multiple instances of an application, or even just a single instance of an application. You want to put something in front of it to give load balancing, or also to provide a level of protection, or just even indirection. So the ability for multiple pods. So here we got, these things are labeled as blog servers. So pod 1 and pod 3 I want to be able to access those two pods through a consistent single interface. That's the service. So the service sits in front of the pods. And whether those pods come and go, so if that gets rescheduled onto a different node, if something dies, or you bring up a new version or whatever, the service stays the same. And that's what's exposed to the rest of the system. And the pods come and go. So again, in the same way that you might put a load balancer in front of things to do exactly the same thing with physical or virtual hardware already, that's the Kubernetes equivalent there, is the service. This idea of labels you'll see a lot in Kubernetes are the things that identify what it talks to, how you select that. Now, once upon a time, at the start of Kubernetes, which isn't that long ago really in terms of IT, started with the idea of pods and services, but then you get to that question of, this is great, so I got my abstraction here of the pod, I've got my abstraction of a service. Now, what if I have that site that needs 20 Nginx servers? How am I going to manage that? Well, I really want to treat those things as one set of services. One set of pods. And so what you would have to have there is a 20 pod object sent to Kubernetes. They're all the same apart from the name, so you need something that groups those together. So one of the things that they quite quickly evolved away from but added to was, you had the pod as that basic construct. We need something that manages these sets of related pods, and that's a deployment. And the job of a deployment is to say, well, actually, in particular, number of replicas, this is the key thing. So I'm going to have something that consists of 3 instances of this pod. So this slightly higher level construct is generally what you're dealing with much more often than the pods themselves. Okay? And within the specification for a deployment is the details of the pods themselves. Sorry, rushing through this because I appreciate some people already know this stuff. And if you don't, one of the things we would encourage you to do is, after this, is make use of Kube Academy, go back at your own pace and take a look at some of this stuff in more detail. So those are some of the fundamental things we're going to deal with, some of the things you're going to see in action. And in fact, what we're going to do is, first lab is we've taken a lab from one of the learning paths, as Ryan has said, that's just going to give you that basic taste of using Kubernetes to do a couple of deployments, expose the services, and see how those things appear. So, what we'd like you to do is, if you open start up the lab environment here, so log in, start the lab. Now, you'll either have the virtual environment there, or, as I say, you can go to the top level browser itself and go to the URL that we showed, which was that's the one. So Kube.Academy/Explore 2023. Yep. Quick question over there. Whoops.
You go here.
You need to get scanned. Right. Okay.
And then it should take you to this page.
Sorry. Yeah.
And we're going to do the first lab, deploy applications using Kubernetes. You'll click there, you'll click that launch button. It looked like right here. If you refresh it another time, don't worry, it'll continue to take you back to your session.
Yeah, and if you can't log into the environment at the moment, that's because you need to get your badge scanned, and we'll try and get somebody over to do that very quickly.
So we're going to take about 10 minutes for this, 10 to 15. We'll come around, make sure everybody's able to access it. If there's any problems, we'll address it. And then I'll come back up, we can do some demoing, and then we'll start the next section.
Yeah.
Okay. I'm going to just see if there's any active questions, and if not, I just want to go through a few things while some people are finishing up. I know some of you are finished. So you can see we worked with pre-built images here. So if you're familiar with Docker, right? What is this? Small, isn't it? Let's make this a little bit bigger. Get some vertical. Screen real estate, yeah, apologize for the lack of vertical screen real estate on the site. It should eventually get better. So we had these pre-built Docker images, and that's what we're using. So, in this lab, we're essentially assuming, right, with Kubernetes that you already have Docker containers you want to run. And when we put it all in, that concept that Neil talked about, we have services, and we have deployments, and we have pods. If I can type. Now, some real quick things here. These services that Neil said acted like a load balancer. Notice that in our diagram back on the slides, typically a web server is the only one that talks at a database, and we don't expose the database on the internet. And so if we have time later on, we'll go about it, but that's why these have different types, these services. So the actual web front end is only the only one that's going to talk to the database through that service, and then our actual public internet is going to talk to us on this other service. Once again, they're like load balancers, and we tend to put services in front of everything, even databases. Remember when Neil showed a deployment and was talking about a deployment and saying it was a way for us to make lots of pods? That's what this 2 of 2 is here. We had the number, if you looked inside there, it said replicas. I like to think of that field as number of pods instead. That was 2. And then if I get the actual pods, which are the lower level fundamental concepts, now I get all 3 back here, as you can see. All right? And then they're in this running state. Kubernetes can restart these things, etc. So what we've done is we've moved up the stack, right? If we think that a pod is like a VM, and the installed applications inside a VM are like the containers in a pod. That's really how it goes. And so now we're talking, and that's going to lead into our next section here, when in Kubernetes, it starts to go above just infrastructure management, and it also standardizes how we deploy applications as well. Let me pause here. Any questions in the current lab before we move on to the next topic real quick? Throw a lot of diagrams up real quick, and then do a lab on it.
Shadow on your face is really bad.
Okay. Okay, so next up, let's switch back to slide land real quick. We'll promise won't make it too bad. And talk about deployment management. So a pod is like a VM, and the installed applications on a VM are like the containers on a pod. Or sorry, the installed applications of VM are like the containers on a pod. So a lot of times people ask me, well, Brian, should I have one pod with 2 containers, or should I have 2 pods with 1 container each? And the question boils back to the same thing with VMs. Well, for your business case scenario in your application, would you put both applications on the same VM, or would you put them on separate VMs? That's fundamentally how this goes. Neil said before, Kubernetes is all about the concepts we know in the data center, but done in the Kubernetes way. So just like we can standardize a lot of things, then we have how do we install applications onto the VMs? Well, many times you'll have your Python team, your Java team, your .NET team, all your different developers may install applications different ways. And there might not be a standard to it. And you have to sort of manage this, right? Those teams have to do this. Kubernetes not only provides the infrastructure, but it also standardizes how we deploy the applications in our data center. So, cliche way is we turn VMs over to application teams a lot. They put the apps on them, they upgrade the apps on them, et cetera, but they're sort of there and it's not fairly standardized, and depending upon your level of sophistication and how you interact with your app teams, you maybe throw it over the fence, it may be more DevOpsy. Kubernetes is going to standardize this, and we're going to see it here. Now behind the scenes, in those deployments, Neil said there were three big things: pods, services, and deployments. Well, there's another object in between there. We intentionally hide it at the beginning because it can get in the way, but that's a replica set. A replica set is a set of pods that are identical to one another. So they all have to be the same version, all have to have the same configuration. Now, let's think about how do we upgrade the version of a web farm. If I have an application running on 10 web servers and I want to upgrade it to the new version of the app, I typically do a rolling deployment so there's no downtime. And sometimes for the sake of like a MySQL database or something, we actually take a downtime if we need to do a deployment of it, depending upon the topology. That would be this recreate. Kubernetes is going to standardize this for us, and let's see how it does it. So imagine this big gray box here is the deployment. So that's like what you just did in that lab when you apply the deployment YAML file. And it has 3 pods defined in it, and on the container line, the image line, image colon, it says nginx colon 1.13.1. That's the version. Well, we want to update that. Well, we don't have to write any special code, any special build or deploy scripts. Instead, we update the line in that YAML file, and we apply it back to Kubernetes. And this is what we're going to see happen if we were to slow down time. You're going to see it in the lab as well. It's first going to say, well, I need to make a new replica set because this is a new configuration of the app. And it's going to start up one pod. Assuming this pod starts up successfully, it will continue in the process. If it doesn't, it will stop, and it's up for an administrator to interject. Assuming it went well, it's going to say, okay, well, I know how to do this. There's one. Traffic is flowing across all 4 pods, and then it removes one from here. It adds one here, removes one from there, and so on and so forth. Kubernetes, if you think back to the Kubernetes as a car air conditioning system, we told it the state we wanted to get to, which is we want everything to be running 1.13.2 of nginx. It's changing. It's saying, oh, this is 1, this is 3. Okay, now this replica set is 0, this one is 3, and so on and so forth. It's making all those decisions to get us to that desired state. The old replica set will actually stick around because it needs to be there for an undo or a rollback. Okay. Once again, this is pretty cool because as application engineers creating our software, we can just make new containers and then just flip those values. Kubernetes orchestrates all of the deployment activities, which depending upon your software, your ecosystem, your teams, may be custom or may use tooling. Recreate, I'll go really quickly on this one, it's not super exciting. Recreate, remember, it can't have more than one of 2 different versions running at the same time. So we change the value to 1.13.2, we apply it. Kubernetes will tear this down. It will then create the new replica set and scale it up. Once again, not super exciting. You may also know about 2 other kinds of deployments, Canary and Blue-Green. Oh, forgot one. Canary deployments is where we want to, it's not about really functional testing, it's more about performance, load testing, memory leaks, etc. We want to put it out there, have traffic going against it, and see how it behaves. If the Canary pod survives, then we know it's good and we'll upgrade the whole thing to that version. And Blue-Green is very useful in scenarios where we need a quick rollback, right? We'll see the diagram on that, but that's like, when we're talking 3 pods, we can roll back pretty quickly. What if we were talking 300 pods? it would take a little while for the system to chug back and forth and get back to the old version, as opposed to just flipping back very quickly. So, how can we do these in Kubernetes? We can use the same fundamental concepts that Neil told us with deployments and services. The pods are going to be there too. So, same diagrams here. What we've added is snippets from, this one is of the deployment and this is of the service. The important parts here are the labels. If you remember when Neil showed the services, if you can think back to that, the labels were like a query matching to say, what pod should I send traffic to? So in this scenario, we're sending traffic to any pods that have these two labels on it, which is all of this, okay? Let's introduce the canary. So we can make a second deployment, call it canary. We set its size to 1. Because it still matches this here, traffic's going to go to it. This allows us to sit in this state for a given period of time while our support team, QA team maybe, monitors the system and says, hey, is this thing doing okay? Memory's increasing and then it crashes. Maybe we have some reports from users that their traffic's getting routed to that particular pod and that app on it. If it's all good, we can move forward. If it's not, we'll delete the canary or scale it down to 0 and we'll just leave it with the old version. If it was good, well, we can change this one back to 0 and we can change this one to the new version, and then Kubernetes will automatically do the rolling upgrade back up there for us. And does anybody have a guess, if we were back here in this scenario, and if I wanted to give somebody a URL, like the QA team, to go directly to any of the pods that are in this deployment, any guesses on what you would do? Service, I heard? I think I heard someone say a service. Yes, we could make a second service where the selector here would have 3 labels in it, and it would match on track canary. And any traffic we send at that service would only go to this pod, because that's the one that matches. Finally, the blue-green one. This is where we have large amounts of capacity or a large pocketbook, and we can have our production running here, and then we make a duplicate, which is green, of the exact same capacity that we need. So obviously we're not going to put 300 pod boxes on the screen here, but imagine that was 300 up there. We duplicate another 300 running. We got it staged there. Notice our selector is only matching on the top pods. When we want it to go live, we flip the switch. So we update the selector on the service object to be green. New traffic will flow in here. Old traffic that had established connections will stay there until they close, and then we're good. And if we want to switch back, obviously we do the same thing. Eventually, we want to recover some of those resources that we're spending, so after we've determined that the new version is safe, then we can scale down the other one and let Kubernetes do its thing. Once again, the advantage here is quick cutover and quick rollback. Now, obviously, depending upon your business application, you might have nuances that you got to check or deal with, but fundamentally, from a concept perspective, that's how we would do something like this. Okay. You can, I'm not here to teach you the docs, but if you go and look at kubectl rollout and apply, there's a bunch of options there. We can pause these things as it's doing its ping-ponging of the pods between the various deployments and replica sets. And then if you have special needs with your application, such as it has long startup times, and things like that, there's a bunch of tunable knobs that affects that deployment, right? For example, back when I said, what if you had 300 pods? Do we really want it to do one at a time? If I have 300, I could have it take a bigger percentage down at a time. It might take 10 down at a time and put 10 new ones up. So a lot of tunable parameters there. And we are going to see all of this in action in the next lab. I'll pause for any quick concept questions before we get hands-on again. Okay, awesome. So once again, if you have this tab open, hit that URL, and you should get to here, and we're going to do deployment management. And once again, the other lab, if you didn't get it done, or you tried to break that environment, awesome. I hope you do, and if you do, come show us, and we'll document it. But outside of that, you can launch the next one, and it'll start up and bootstrap for you. And we'll be back in about 15 minutes to 20, depending upon, and I'll maybe do some demoing again once Neil and I assess the stuff, and we can, because this one's got some fun stuff in it.
A lot of people have probably finished, some haven't, that's okay. Don't worry, again, you can come back and do this at your leisure, whenever you like, as many times as you like as well. So any questions from that at this point? Anybody got any issues, any queries about what you've just done? Again, this whole issue of how you use Kubernetes to do this, it's got some of these patterns built in. You've seen some of the other patterns that you can apply. And how you do things in your own organization is very much up to you. Kubernetes gives you some of the tools. In fact, this is obviously one of the areas where you look at other things that can be layered on top of Kubernetes as well that add value. One of the well-known people in the Kubernetes world, Kelsey Hightower, said, he tweeted, or X'd, I suppose, these days, didn't he? He didn't tweet. He said that Kubernetes is a platform for building platforms. And actually, as you learn more, you'll discover that actually that's why, in many cases, you add additional things to it. I would say stuff like Tanzu Application Platform, build on top of that to give you some opinionated ways of doing things. And I guess that brings us on to another topic at this point, which is, so actually you have to make some decisions in your organization as to how you're going to deploy this stuff, how you're best going to use it. I better just unlock that. Thank you. Okay, that's fine. And often when you start out with Kubernetes, you may start out doing stuff on a local laptop, playing with Minikube, Kind, that kind of thing, or spinning up a cluster yourself, and you have full access to everything there. And in this case here, you're just working in one area and you're forgetting about everything else. But when it comes to a real live deployment, you've got to think about other issues. So how can you organize your resources to best be used? And at the highest level, the cluster. So a group of nodes that are working together, and that's where we talked about pods. The pods are scheduled on the nodes within a cluster, and that's kind of the boundary of what you work with. And that is the highest level of isolation, but it does come with a cost. You've got to manage these machines, you've got to deploy these machines, you've got to manage them. But there are circumstances where you absolutely want that level of complete isolation. So different environments, production versus a QA environment, classic one. Another one that's very common within, say, finance or health is where you've got really strict compliance requirements, where you absolutely cannot mix different applications from different parts of the organization or for security reasons. So compliance is one of the ways that one of the things that will drive you to putting things on separate clusters. And geography is another thing. So Kubernetes clusters assume that they have a pretty high bandwidth and low latency connection between the nodes. So you may have different nodes in different availability zones, but you're unlikely to put them in different geographic regions because that's going to have a bad performance impact. So that's, again, one of the things that will drive you down the particular route of choosing to have separate clusters. And there are other factors as well, just some examples there. But those, again, are probably the same kind of issues that you're already familiar with. They're the kinds of decisions that you already have to make when deploying applications. What are you going to do? However, so clusters are the highest level concept for organization of resources. But within that, there is the notion of these things, namespaces. In fact, you've already experienced namespaces without realizing it. So all of you here are using the same cluster. It's quite a large cluster. It's got about 20 nodes in, but you're all actually using the same cluster. And each of the pods that you've scheduled could be scheduled on any one of those nodes. But you haven't seen anybody else's applications. You've done a kubectl get pods, and you've just seen the things that you've deployed. That's because they've been partitioned by namespaces. A namespace, again, a way of structuring and carving up the resources within the cluster. Now, one of the first things is, yes, names need to be unique within the namespace. It's one of the ways of allowing everybody here to have deployed Go Web App with the same name. So that name needs to be unique within the namespace, but can be the same name across different namespaces. And going with that, it scopes down the names of services. Now, you haven't seen particularly explicitly the names of services, but you'll have deployed a Go Web App service. In fact, that's the short name that you're dealing with, but it does have a fully qualified name that goes across different namespaces. So if you're referring to that service within the namespace, you can use the short name. If you want to refer to a service that's in a different namespace, there is a fully qualified version. Service name, namespace name, .service.cluster.local. So another one of the ways that namespaces are used. And of course, one of the key things you might expect is this is also a boundary that you can use for applying security and access control. And also resource limits and things like that. So your namespace is your boundary for that, your unit of administration. So you might quite reasonably have a single cluster that's shared between different development teams, and you partition it up and give one team access to one namespace, one to another, or different parts of the organization, so say R&D, contractors. Or you can carve them up in a different way. You may do it based on the systems. Again, it's a tool there. There's no, Kubernetes doesn't care how you particularly use them. It's just that tool, and that's an organizational decision that you need to make. And your organization may well already be thinking about policies for how you're going to do those things in your organization. So that's namespaces and clusters. Now, one of the things that probably surprised me when I first came across Kubernetes was, okay, so how do I add new users and all that? And it's like the notion of user management takes a little bit of getting your head round to begin with, I think. And in particular, how, I haven't logged on to the cluster. I've just run things. How did that work? What was happening? And what is actually happening is, by default, it's using a file that's located in the .kube directory, in the home directory, .kube/config file. And that's another YAML file, and it's got some different sections in. And if we look at those, there are 3 sections that you'll find in there. So one talking about the clusters. So this is, you can use this same file to talk to different Kubernetes clusters. So what does it mean to talk to a cluster? Well, you need to know where the API server is. So this is one of the key components of a cluster, is the API server. And that will have a URL for it. So HTTPS cluster API. That's part of what you deploy when you deploy a cluster, is the API server. That's what says it's there. And because the traffic to that is encrypted using HTTPS, you will need a certificate authority data that goes with that. And you can give that cluster a name, and you can have multiple clusters in there described by name. The other thing, where it talks about users is perhaps misleading because it's really just a set of credentials that can be presented to a cluster API server. So it may represent a user, it may represent a service account, may represent something completely different. And what a user section really is, okay, what credentials do I need to present, or what credentials have I got that I can present to a cluster API server? So you've got those two pieces of information in this file. And then there's one other thing that ties those together, and they talk about contexts. So a context is a combination of a cluster and the credentials that you're going to use for that. So you can have the same credentials that are presented to multiple clusters, or it could be different sets of pairs of information, or you could have two sets of credentials which have different privileges that are presented to the same cluster. It's a different context. So that's the thing that you have to get your head around. So you've got details of what clusters you can access, details of what sets of credentials you can apply, and then this thing that ties them together, the context, which is the pairing up. Now, the other thing about this file is that this is one of the things that can be modified. So if you log on to an EKS cluster, one of the things it can do is it can go and add stuff to this file, for example, automatically. There's a command that does that, or Kube Control can make changes to this as well. In particular, when you change the context, when you change the default context that you're using, it will go and it will change that line current context that you see in the middle there. So this file will be dynamically modified, and that can catch you out on occasions. Also, if you integrate with other authentication mechanisms, you'll find different things that get added into this file. So if you're integrated with some kind of LDAP directory, you may find different sorts of information that appear in here. So it won't always be in, whilst you'll always have those sections, the actual details that you see in, particularly under the credentials side, will be different. So that's just a bit about that. Again, you'll see something about that, in particular swapping between different contexts in the next lab. And I guess this also leads us on to just talking a little bit about Kube Control. Kube Control, if you're dealing with Kubernetes, you're going to need to know the Kube Control command line at some point. It is the way in to everything at the Kubernetes level, and pretty much it knows what you can do to the API, and a lot of the commands map directly to things that are in the API. In some cases, one-to-one. But anyway, as far as that is concerned, one of the things that you will do is say, okay, which namespace am I operating with? So for any command, you can say, I explicitly want to do something in this namespace. You can set what the default namespace is at any one time, but you can also explicitly say, I need to operate in this namespace. Kube Control set context is that thing about saying, what is the current set of credentials that I'm using? Again, this is something that you'll definitely use for swapping between those contexts. And something else that you will use a lot, and it's worth learning over time, is different ways of getting output. So again, if you want to interrogate details about things that are there, you can get different levels of output. So you've seen the Kube Control describe command, which is kind of user-friendly, but you can get stuff out in more JSON and YAML format, which is great for feeding into other tools. So if you're doing automation at any point, you make a lot of use of that kind of thing. Again, worth understanding those over time, and also do stuff like sorting and so on. So Kube Control is your friend. It can be a bit intimidating to begin with, but taking the time to learn and become familiar with that will make your Kubernetes journey a lot easier. Okay, so I think then we are on to the final lab that we're going to do here.
Yep, and so we like to always end with the lab. That way if you finish early, you can just go ahead and go. We do thank you, and also remember, if you want the 30-day free trial of Tanzu Academy, swing by up here and we'll make sure you're enrolled. We'll be going around for questions, and then at the end, once again, I'll demo if there's any questions there. Thank you again. Enjoy the time here at Explore, and hope that maybe something on one of the 3 academies will help you in your Kubernetes, Tanzu, or Spring educational experience.
And certainly we'll be around here for a while. If you just want to chat, ask other questions, feel free. So we've got nothing else to do this evening, have we? Well, Ryan probably has. He has a life. But other than that, yeah.
3
thank you
sessions
very much.
down, so thank you all.